This is breaking a vector down into x and y components, example 2. This time we are looking for the x and y components, or pieces. Components is just a fancy word for piece. Anyhow, the x and y pieces of a 21 meter vector that is going at 75 degrees. Okay, so this is, we're estimating to be about 75 degrees, and this would be 21 meters. Once again, we can visualize the x and the y components. So here is my x and here is my y. As before, I'm dealing with the hypotenuse and the opposite. So the hypotenuse and the opposite, according to the SOHCAHTOA mnemonic device, is going to be the SO, which is, okay, the sine of theta equals the opposite over the hypotenuse. Now, in physics terminology, we're just going to be saying sine of theta equals y over r. So if we're solving for the y, that means all we have to do is bring up the r here. So r times sine theta equals y. Plugging in my actual values, I have 21 meters times sine of 75 degrees. Tap that into my calculator. So I have y equals 20.28 meters, or rounding to 3 sig figs, 20.3 meters is my y value. Now for my x value, this is the adjacent, and I'm still going to use my hypotenuse. I don't want to use my opposite because what if I messed up? So I'm going to try not to use something I just solved for. So if I'm going to use adjacent and hypotenuse, then that means that's the CA section of SOHCAHTOA. Okay, that means cosine of theta equals the adjacent over the hypotenuse, or using our physics terminology, cosine of theta is x divided by r. Once again, I'm bringing the r up here, so I now have x equals r times cosine of theta. Plugging my values in, I have 21 meters times the cosine of 75 degrees is my x value. So tapping that into my calculator, I would have 5.435 meters, or rounding off to a little more reasonable sig figs, that would be 5.4 meters is this value. Now, once again, I should check to make sure that makes sense. If I have 21 meters as my resultant, which is up here, then yes, my x and y values are in fact smaller than 21, but 21 is in itself smaller than the two x and y values added together. So that's a neat little trick I can use. Also, if I'm looking at the angle, this is 75 degrees, which is definitely more than 45, which is definitely going to be the y is going to be the larger of the two. So that is something I should keep in mind. I know from geometry class that the side of the triangle that is across from the larger angle is going to be the larger side. So 75 is pretty big. So that means it is completely reasonable that my 20.3 meters is there, and that my 5.4 meters is on my x. Physics.